Hi everyone, I'm Zhao and I work in Google. And today my topic is implement ranges starts with and ranges ends with. So first reason why we need to range starts with and ends with. The first reason is very simple. We don't have one. Yes, there's a one in algorithm headers, but it's string only. And the second reason is that range library is more composable, more readable, simpler, and less error-prone. For example, we already have SD sort, and you can see the classic version and the range version. The range versions is easier to read, and developers don't have to write function from the scratch. And more detail, you can see CVV stories. And how to implement. So the starts with is an easy one. We pass through ranges and their projections and the binary predicates, then call mismatch on the inputs. If it returns the senator of the potential prefix, then the prefix is found on the first range. And ends with is a little complicated. Same input and similar output. If the answer is yes, congrats. The second range matches the suffix of the first one. Otherwise, it doesn't match. The algorithm details will be introduced in the next slide. So there are two types of input, iterators and range. Some optimizations will be introduced below. So if we pass iterator and if it's a bidirectional ones, we can reverse the iterators and call starts with algorithms to see the results. The constant type operation will call minus under the hood, although it looks like the starts with call plus for the reverse iterators. This is our first optimization. If it's not a bidirectional one, we will move the beginning iterators of the first range until two ranges have equal size. Then we call equal algorithms to see the results. And if we pass ranges, and if they are size ranges, lucky for us, we can get the size at constant time. This is the second optimizations. And the third optimizations for random access iterator input. Because ranges equal contains a powerful memory compare optimization for contiguous iterators. So random access iterators will still call advanced and equal. So this is the benchmark results. All inputs are integer list. So they are more generic, not limited to string type. And something interesting here, you can see the random access iterators, it's a bit slower, which is not expected. And Konstantin Vermont finds that the memory compare optimizations doesn't get triggered, so there's some further work to do. But in other optimization like the forward iterators with size optimizations, the result is really great. Once the second range is longer than the first range, we will return round immediately, and we will save time. So to trigger the memory compare optimizations, we need to modify these chains to recognize the wrappers, so the equal won't be slower than mismatch. And thank you, Konstantin Vermont and Nicola Klaus for help. And thank you for listening. If you have any questions, feel free to discuss with us. Thank you for your listening.